everybody. My name is Brendan O'Maloney. I own a company called Tenthouse Structures. We are based in Cape Town, South Africa. And I've been in the luxury experiential lodging and architectural fabric structure design space for about 25 years now. Today, I'd like to talk a little bit about a project that we completed last year. But first, just a little bit about my company. Tenthouse Structures specializes in the design, supply, and site assembly of luxury tented camps and lodges into Africa and beyond. Tensile membrane roof structures are the core infrastructure offering, to which we combine thin envelope enclosures, canvas mostly, insulations and so forth, delivered in flexible design-to-build solutions. I'm going to dive straight into it. So Camp Sarika was a project we completed for the Amman Resort Group, a prestigious wild resort group based in Asia and the United States mostly. This project was an extension of an existing and rather iconic hotel in Utah, in the Grand Canyon. They were looking to create a tented add-on to the existing hotel. We were appointed as the tent technologists. We collaborated with some very accomplished designers, local engineering, manufacturing, and construction teams to create this extraordinary project. This project is set in the Utah, the rocky escarpment in the Utah, very beautiful views of Lake Powell and the surrounding escarpment, wind-sculptured mesas, big sky backdrop of the Colorado Plateau. I would say that Camp Sarika is a masterful work of nature-adaptive form and function. Historically, the Amangiri Hotel had tried to introduce some tented concepts into the area. They'd use teepees and other rather fun and quirky tented concepts, but really this sort of glamping approach was not aligned to the luxury brand of Amman Resorts at all, and they soon lost interest when damp and wind deterioration and other comfort issues developed. And they were looking for a more long-term, high-performance, all-weather product. So Tenthouse Structures was approached. They discovered us via our groundbreaking work on the skeleton coast of Namibia on a project called the Hoanib. And we were asked to reproduce this type of concept in Utah, but obviously technically this did not make much sense because the product we used in Hoanib was a flexible, stretchy type of membrane, which is fine there, but not in a snow load environment, and certainly not in a project which was looking for 20-year sort of lifespans. They needed something superior. So we decided that tensile membrane technology was definitely a preferred roof tech to the stretch membrane technology for this project. We were up against some well-respected US-based firms and were able to win this project, not so much on the price, but on our experience and specialist knowledge in the detailing and creation of luxury wilderness lodges, a strong understanding of the guest experience and what works well in the wild. So the brief to us was as follows. Our scope as the turnkey tent specialists was to form, find, engineer, specify, detail, supply, and install the tensile membrane roofing structures and the full canvas envelope inside and out. We were further consulted to provide the steel frame modeling for manufacture in the USA. So already there was this blended, integrated service and supply component which had to be very carefully managed in order to give the client a cost-efficient product and a product that allowed for enough local skills and materials to be introduced to the project, as well as drawing on our specialist expertise. So it was a real alignment of an international team of Africans and Americans. We had to produce a prototype on the site for both the architects, ourselves, and the contractors to proof detailing, test run performance capabilities over a full season cycle and optimize the construction process. Prototyping in our business is, especially for these one-off iconic projects, is really essential because you're going to be delivering not just one product, but a series of them. And if there are some flaws or some functional issues with them, you don't want to be repeating that. So the guiding principle was to be as efficient, i.e. lightweight, as possible, with no compromise to aesthetics and performance standards. So this leads me to what some of our technical challenges were on this project. Firstly, the tensile membrane roof structures. Tensile membrane form and engineering is an iterative and integrated discipline. As Fry Otto calls it, a bionic design, where form and function are inseparable and influenced by multiple factors. The key factors at Camp Sarika were the design demands and limitations. Number one, the building code, of course, the imposed safety and shape factors for the state of Utah, the high winds, 90 miles per hour, a fairly light but nonetheless existing snow load of 6 pounds per square foot, an exposed terrain and wind funneling, some extreme temperatures, the range of temperatures, which is quite typical in the US actually, in Celsius ranging from minus 15 or minus 20 to 45 degrees plus in summertime. And of course, that also impacts on the fabrics temperatures, which are minus 20 to 90 degrees Celsius. And then just the maintenance of the product was also a bit of a technical challenge. All of these presented a substantial set of challenges to the frame engineering, the cable support elements, the membrane fabric, the shape, the size, the detailing, and deflection behavior of the membrane. Just a little bit on the bionic design challenge. Flattening the roof to the allowed maximum height out of the view of the main hotel was a requirement. It limited the amount of curvature we could build into the membrane system. And as we know, the more shape, the more curvature, the more the ability of the membrane to resist live loads. This in turn influenced the fabric selection and reinforcement techniques, as well as access to and views from the suites. The shallow roof angle and membrane deflection would result in ponding and the membrane touching the structure beneath. How we overcame this was to reduce the height of the perimeter masts, extend the canopy out beyond the enclosure beneath, and introduce under-fabric cables, and then cut dramatic, strategically positioned scallops along the edge to avoid ponding and to allow entry and light into the area. Another little comment on some specific detailing challenges. As Simon Chu calls it, the torso, which refers to the engineering design of connection points in tensile membrane structures. Torso is critical because it affects the entire structure's stability, durability, ease of installation, and maintenance. The aesthetics too, and the cost. So vector-aligned connection systems, swaged cable ends, high tensile steel U-bolts, specialized washers, fabric reinforcement techniques, all considered. Then we have the aesthetic and performance of product. Working with the architects, we selected neutral fabric color palettes that complemented the surrounding environment, tent architecture, and interior design. This is a very important part of our process. We're working in a wilderness environment where we need these discrete and harmonious colors and textures and shapes. Often quite hard to secure and combine and produce with fabrics that also need to perform at the same time. Nonetheless, this is, as a business, what we do. So the roof, the ceiling, and the wall systems at Camp Sarika comprise of 3 layers, 3 different fabrics. Layer 1, the outer membrane, is an architectural PVC. In this case, it was a Serge Ferrari Type 2 PVC with a matte finish and a PVDF coating on it. Over pretty soon, in a desert environment like this, the surrounding dust settles on these outer membranes, and that shiny synthetic look disappears very quickly. And actually they take on a beautiful natural canvas look quite quickly. Layer 2 is what we term the hermetic ceiling and the exterior walling. So this is what you would see from the outside of the enclosure. So the ceiling and the outer walling are in a technical canvas that we produce in South Africa. This is a very durable skin with 20, 30 years of tried and trusted in the African bushveld. It's fairly easy to maintain. It can be painted if it fades in terms of coloring or gets stains on it, and it's quite a cost-effective product. Layer 3 is the interior ceiling and the wall linings inside. This is a strictly interior detailing, but nonetheless, this particular fabric is a fabric that is a proprietary fabric of our company, which we've developed over time to imitate cotton, but in a polyester with all the right and necessary fire retardancies and so forth. It's a textured weave product which we pattern into the ceilings and onto the walls. Very important. This is a very high-end finish. Seams need to align, and the detail is where it all happens. Obviously, all our fabrics have to meet the correct fire retardant standards in the United States. The NFPA 701s, the California State Marshal fire retardant standards. All fabrics had to go through the biaxial testing for their modulus characteristics under specific pre-stress and design life load scenarios. And in collaboration with our textile partners, Layer 1 and Layer 2 were developed with built-in heat shields to block all transmitted light energy. In this case, in our business, translucency is not always your best friend because of dust and dirt, and with the darker fabrics particularly, we want to really optimize our optical properties to reduce any kind of to reduce heat transfer. Layer 3 was developed, the ceilings, to emulate the soft handle and texture weave of a duck cotton canvas, as I've said, and other topical treatments for easy maintenance and dimensional stability. A little bit about the integrated building systems. So the frame itself, Tenthouse Structures, we engineered the steel roof trusses and the piston masts to fit onto a timber subframe made locally in the United States, and the outriggers to tie into submerged footings. Working with local structural engineers, we integrated the steel with the timber to work as a homogeneous tensile system. Connection detailing and complex structural behavior were resolved. Tensile membrane engineering is obviously a precise discipline. The construction of the perimeter footings and frames was set out according to design and surveyed post-build. That survey information was relayed back to our engineering team, whereupon we recalibrated the membrane system design to as built before we manufactured it. This is always a challenge with sort of high-end projects with a free exterior, an uncontained system where you've got tie downs which aren't returning back to a frame as such, as you have to go through the survey process. And this can often hold up procedures, and it's in our business, time is money, because every day that the hotel is open is a day that they do not have revenue. So we have to develop very close relationships with our international partners to ensure seamless and smooth delivery of these collaborative projects. In terms of the envelope, our canvas linings and claddings were detailed to connect to the timber stud wall envelope in this case. This entailed such complexities as lace tension ceilings, top-fitted wall profiles, ring beam profiles, and canvas-clad corner trims and eave valance systems. The hermetic ceiling, the exterior ceiling, had to be fitted onto non-orthogonal timber faceted surfaces with custom extruded profiles. This was quite complex because as much as we tried to resolve this in the design phase, because all of this is made off-site, working with local contractors was the challenge was that we are used to working with very fine tolerances and local contractors not so much. So once we got to site, our team of specialists had to make quite a lot of adjustments to the timber surfaces to make sure that system lines were correct and so forth. So altogether there were about 6 key role players on this project between South Africa, the designers and the tent technologists ourselves, the architecture interiors, and then the Americans, the client of course, and the steel company and the contractor, the general contractor. Another great challenge of working in foreign environments, which is something we specialize in, is the imperial versus metric systems. And it sounds like, why would that be a problem particularly? But it's working with engineered systems and fine canvas details does require a high level of discipline to convert from metric to imperial and back again. It's not a learned behavior if you're used to working in one or the other. The consequences of conversion errors can obviously lead to misalignment of integrated systems or system failure. So this is something we obviously to monitor closely. And then the other challenge is time zones. Working with time differences between design and field teams in both South Africa and Western United States requires a committed approach, rigorous forward planning, and after-hours contactability. Okay, so some of the other challenges that we faced is we handled this somewhat of a turnkey process here. So we're engineering, we're detailing for fabrication, we're manufacturing all the soft components and specialized tensile components. And we're handling all the logistics for this, consolidating, packing, labeling, export manifests, loading, sea, air, and road freight, and debunking it on the other side. And then once we've done that, our specialist site team arrives on site and works with local appointed contractors and labor under our guys. Navajo Indian teams, American teams, Mexican teams, a real collaboration of cultures and people. The site operations for this type of project are extensive and highly specialized service. They cover storage, preparation, programming, crew supervision, tensile rigging, canvas fitment and snagging. And this is all in a remote environment. Whereas, say, in an urban environment, if you're short a tool or some hardware, or you need to, you've got a power problem, it's generally resolved quite quickly. In a remote environment, that problem becomes increased by an order of magnitude. So it requires an enormous amount of planning, but it also requires a certain type of individual who is used to and experienced in working in challenging environments. And our team of South Africans have built lodges throughout Africa, and very used to these kind of challenges. Rigging the tensile roofs, in this case, these large span membranes are vulnerable to wind and snagging damage during erection, which is typical with all tensile, large span tensile structures. The difference here, of course, being that the environment is a little dustier, and the equipment available is a little bit more simplistic than one might necessarily have in an urban environment. The expert rigging team from South Africa and North America, our expert team, planned accordingly for these conditions. Some of the planning involves the following techniques: saddle strapping the membranes along horizontal boom rigs, lowering them onto position over the cones with one man positioned at each cone head, fixing the cone heads with membrane partially wrapped to avoid flapping, then rapidly unfolding the membrane during calm conditions with one man per connection point. This is obviously a critical period. Then connecting the perimeter points to pre-installed masts, raising the membrane, and achieving a first fix in one rapid contiguous process. This ensures the entire membrane had enough pre-stress to afford adequate structural stability for the now protracted final fix process. A little on some troubleshooting that we have to deal with at Sarika. The locally constructed shell, as I mentioned earlier, was a typical North American OSB clad stud wall frame with a polyurethane insulated fill. The as-built versus the design tolerances were at times beyond the tighter acceptable tolerances for pattern fabric systems. Our expert technical supervisors were able to make complex on-site corrections to the shells and to our interface systems. This hands-on problem-solving approach comes from years and years of experience developed building in the bush in Africa. And just lastly, a little word on team culture. As with all of our Tenthouse structures projects outside of our home turf, cultural assimilation between professional and site teams is a valuable soft skill developed over the years of working across borders. We, in fact, relish the opportunity to work with people with different backgrounds. And in conclusion, these iconic tented style suites in Utah are pioneering the future of performance fabric technology in the United States eco-hospitality landscape. We answered the brief with iconic, efficient, high-performance structures where the guests can intimately reconnect with nature. This is Camp Sarika. Thank you very much, and I look forward to hearing your questions.